Helen believes that the random variable C, representing cloud cover from the large dataset, can be modelled by a discrete uniform distribution. Part A asks, write down the probability distribution for C. Now, for this question, we need to have some knowledge of the large dataset, and more specifically, we need to know about cloud cover and what it's measured in. So if we were to look at the large dataset, we would see that cloud cover is measured in octas, which is a way of measuring cloud cover that has a range of 0 to 8, which means cloud cover can only be an integer between 0 and 8. There's no decimal points in this system, which means it is discrete, which is something we're told in the question as well. So if the random variable C can only be an integer from 0 to 8, we can draw this on a table. So if we draw out that lowercase c can only take a value between 0 and 8, then we can say that the probability of the random variable c being equal to one of these 9 numbers must be equal, because we're told in the question that Helen believes the random variable c can be modelled by a discrete uniform distribution. And what uniform means is that the probability of it being 1 must be the same as another. So the probability of c being equal to 0 has to be the same as the probability of c being equal to 4, for example. And this is the same for every single value of c. And then what we can say, because of this, is if there are 9 possible values that c can take, then the probability of each one must be 1/9. And so if we fill this into the table, where every one is 1/9, then this is our probability distribution for c, because this is all the values that c can take and the probability of each. Now, this question was worth 2 marks, and our first mark comes from giving a correct set of values for c, which we have done here on the top row of this table, so giving 0 to 8 as our set of values of c. And our second mark also then comes from getting the right probabilities from this value of c. So getting 1/9 for every single one gets us a second mark. Part B is now asking us to use this model and find the probability that cloud cover is less than 50%. Now, we know that if cloud cover can only take a value between 0 and 8, that 50% must be when c is equal to 4, which we can see on our probability distribution is here, because that's the number that's in the middle. So then we can say that what this is asking is that if cloud cover is less than 50%, that this means that we want the probability that the random variable c is less than 4. If 4 is 50%, then we need c to be less than 50%, less than 4. And now the way we can find this is by looking back at our table, our probability distribution. And we can see that the probability of c being less than 4 must be this probability plus this one, and this one. And the reason it's not the probability of c equals 4 as well is that we want it to be less than 4, not less than or equal to 4. And so with this information, we can say the probability of c being less than 4 must be equal to 1/9 plus 1/9 plus 1/9 plus 1/9, which is the same as 4 multiplied by 1/9, which is 4/9. And that's all we have to say. The probability that cloud cover is less than 50% is therefore 4/9. And now this gets us the 1 mark needed, because we just had to state that the probability of c being less than 4 is equal to 4/9, which we've done here. Helen used all the data from the large dataset for Hearn in 2015 and found that the proportion of days with cloud cover less than 50% was 0.315. Part C asks, comment on the suitability of Helen's model in light of this information. So we just found in Part B that the probability of the cloud cover being less than 50% was 4/9, which is equivalent to 0.4 recurring. But Helen has just found that now the proportion of days with cloud cover less than 50% was 0.315, which is much less than 0.4 recurring. And so this is quite a big difference in terms of probability. The fact that the actual value is more than 0.1 less than what we thought it might be is quite a big difference, which is not a good thing. And so we can say that the probability is actually lower than we expected it to be. And what this suggests is that Helen's model is not suitable in light of this new information. Now, this will get us the 1 mark available for the question. We just had to state that because the probability was lower, then the model isn't as good as we thought it would be. It's not suitable. And that is 1 mark. Now, part D is asking us to suggest an appropriate refinement to Helen's model. And there are a number of different things we can say, but one of them is that originally we assumed that the distribution was discrete uniform distribution. We were told right at the start of the question. Now, the problem with assuming that the distribution is uniform is the fact that this doesn't take account of any changes in season, in the weather, in different places even. Cloud coverage in one place is not necessarily the same as the cloud coverage in another place, even at the same time. But modelling it as uniform distribution does not take account of this. So we can say that because cloud coverage can vary over different months, different seasons, and places, we should use a non-uniform distribution instead of a uniform distribution, as this will take account of this a bit better. Now, this will get us the 1 mark required for the question. We just had to state a problem with Helen's model and therefore how we would fix it. So a problem is the fact that cloud coverage varies, and therefore we fix this by using a non-uniform distribution, and that's 1 mark. Tessa owns a small clothes shop in a seaside town. She records the weekly sales figures, W pounds, and the average weekly temperature, T degrees C, for 8 weeks during the summer. The product moment correlation coefficient for this data is minus 0.915. Part A asks, stating your hypotheses clearly and using a 5% level of significance, test whether or not the correlation between sales figures and average weekly temperature is negative. So first of all, since this is hypothesis testing and we were asked to state our hypotheses clearly, we have to give a value for the null hypothesis and the alternative hypothesis. So the null hypothesis, which we can write like this, we can say is when the correlation is equal to 0. There's no correlation. And then the alternative hypothesis, which we write as H1, since we want to see whether or not it is negative, we can say that the alternative hypothesis is when it is negative, which is when rho is less than 0, negative. So now that we've got this, we need to find what is called the critical value. And the way we can do this is we need to look in our table of critical values, and we need to look for when n is 8 weeks, or when n is 8, because we were told that she recorded it for 8 weeks. That's our sample size. And then we need to look for when the significance level is 5%, which is when it is 0.05. And if we look at this on the in the table, we find that the critical value is equal to minus, and we call it minus because it's a negative correlation in our question, minus 0.6215. So now we know the critical value, we can also give the critical region. And because we know, again in this question, we're trying to find whether or not the correlation is negative, and our alternative hypothesis is when rho is less than 0, we know that our critical region must be when r is less than minus 0.6215. We always use the same. So if our alternative hypothesis is rho is less than 0, then our critical region is r is less than the critical value. which is minus 0.6215. So now we have this, we need to look up what the product moment correlation coefficient is, and we're told that it is equal to minus 0.915. And if we look back at our critical region, we know that minus 0.915 is less than minus 0.6215. It falls within the critical region. And if this falls within the critical region, we can say that we can reject the null hypothesis, we can reject H0, therefore meaning we can accept the alternative hypothesis, and that there is evidence of a negative correlation between W and T. And now this will get us all 3 marks, because our first mark comes from stating hypothesis clearly, which is what we've done here by saying what our null hypothesis and our alternative hypothesis are. Now secondly, we get a method mark for stating what the critical value is, so using the table to find that the critical value is minus 0.6215. And lastly, we get an answer mark for saying that because minus 0.915 lies within the critical region, we reject H0 and there is evidence of negative correlation, which is what we've said in this last sentence here. Now we're asked for part B to suggest a possible reason for this correlation. So why might there be a negative correlation between W and T? And there are lots of different things that we could say for this. Any valid explanation as to why people might be spending less, shopping less, when temperature increases would get you the mark. But for example, we could say that when temperature increases, it's warmer outside. People might want to go to the beach, go on walks. People might want to spend more time outside instead of shopping. So therefore sales would decrease as people aren't shopping as much because they want to be outside. So that's one answer we can put. And now this will get us the 1 mark for the question because we've given a valid reason. And the key thing is that we've given a reason to explain this negative correlation. Simply describing the negative correlation in context is not enough to get you the mark. You need to give a reason, which here is that people are spending time outside, for example on the beach, to get this 1 mark. Tessa suggests that a linear regression model could be used to model this data. Part C says to state, giving a reason, whether or not the correlation coefficient is consistent with Tessa's suggestion. So if we were to draw out a diagram of the linear regression model, when there is a strong negative correlation, which is what Tessa is suggesting could be used to model this, if we were to draw out a strong negative correlation, we'd have W on this vertical axis and T on the horizontal axis. Just because that's the way they'd be modelled. T is the thing that causes W to change, and therefore they would be this way around. The line is a straight line where all of the points lie exactly on it. There's no variation. The points all lie exactly on this straight line. And for this to happen, we say that R is equal to -1. The product moment correlation coefficient is equal to -1. Now, in Tessa's case, her correlation coefficient is -0.915. And we can see that -0.915 is quite close to -1. They're not too far out from each other. And therefore, we can say that as -0.915 is close to -1, that the correlation coefficient is therefore consistent with Tessa's suggestion. And this will get us 1 mark, the 1 mark available for the question. We had to state that because R is close to -1, so because -0.915 is close to -1, that therefore it is consistent with the suggestion, and that will get us 1 mark. Part D is now asking us to state, giving a reason, which variable would be the explanatory variable. So out of W and T, which is the explanatory variable. And now what this is it's the variable that changes, that then causes the other one to change. So in this instance, we can say that it would be temperature, because when temperature changes, the sales change. The change in temperature is what causes people to stop shopping as much or shop more, that then causes sales to increase or decrease. We can't say that an increase in sales would cause temperature to decrease. Sales can't control the temperature, but we're saying that temperature can control sales. So we can say that temperature is more likely to be the explanatory variable, because sales are likely to depend on the temperature. A change in temperature leads to a change in sales, not the other way around. And this will get us 1 mark, because we have to state that temperature would be the explanatory variable, but we also need to give some kind of implication that W, the sales figures, depends on T, or that it responds to a change in T. One of those words is actually quite key, in the mark scheme states that they need to be used to get the mark. So saying that sales are likely to depend on temperature is necessary for the mark. Tesla calculated the linear regression equation as W equals 10,755, take away 171t. Part E asks, give an interpretation of the gradient of this regression equation. So if we were to draw out this graph, where we know that t is on what we would call the x-axis, because we said before that t is the explanatory variable, which always goes on this horizontal axis, and therefore this axis here is the w-axis. If we were to draw the graph, we know it has a really steep gradient, and the way we know this is because a gradient of minus 171 means that for every 171 it goes down, then it goes across along the t-axis by only 1. And therefore, an interpretation of the gradient of this equation is that we could say that for every singular degree rise in temperature, the weekly sales figures, W, drops by £171. So there's only 1 mark available for this question, and the way we get it is from saying this, so stating that every 1 degree increase in temperature leads to an £171 decrease in weekly sales. In an experiment, a group of children each repeatedly throw a dart at a target. For each child, the random variable h represents the number of times the dart hits the target in the first 10 throws. Peter models h as binomially distributed, where n is 10 and p is 0.1. Part A asks, state 2 assumptions that Peter needs to make to use her model. So first of all, we know that this is a binomial distribution, and the way we know this is because of this b here. So this tells us this is a binomial distribution, and that's the first thing we need to look out for. So now we know this, we know that there are a set of assumptions that come from modelling with a binomial distribution, things that we have to assume for it to work. For example, one of these as a general statement is that there has to be a fixed probability of success, which is p, and we've said before that p is 0.1. So this has to be fixed. Now, in the context of the question, what this would mean is that the probability of a dart hitting a target, because that's what we now define as success in this context, the probability of a dart hitting a target has to be fixed. This must be constant, regardless of which child it is or which number of throws it is. And now a second assumption that we have to make is that in general, that trials have to be independent. And again, in the context of this question, we define a trial as the number of throws, because we said the number of trials, which we call n, is 10, and we know that there are 10 throws, so each throw is a trial. And we have to assume that these are all independent. So if you were to hit the target in your first throw, that doesn't affect your chances of hitting it in one of your other throws, is what we mean by independent. And so we have to assume that each throw doesn't affect the other. So that can be our second reason. So now we've given 2 reasons, as we were asked for, and this will get us both of our marks. We get a mark for each point, But the mark scheme is quite specific with this. There are specific words we need to use. So for the first bullet point about the probability being constant, we must use the words probability or any equivalent word such as chance, possibility. And we have to use the word constant or fixed or the same, a word implying constant. We need to use both of those words to be able to get the first mark. So they're quite specific about this. And similarly, for our second mark, the second point about throws being independent, we need to use the word throws. They don't accept the word trials, suggesting that they need the answer to be in the context of the question and not just a general assumption we make for binomial distribution, which is why they need the word throws. And we have to use the word independent as well, but this will get us our second mark. Part B is now asking us to use Pater's model and find the probability of H being greater than or equal to 4. So there are different ways we can solve this, and it does actually depend on the type of calculator you have. So some calculators are able to, using this distribution, where H is binomial when n is 10 and p is 0.1, some calculators are able to find the probability of H being greater than or equal to 4 just using that. And that's for calculators that in the binomial distribution option, you can put in a lower and an upper bound, where you'd put the lower bound as 4 and the upper bound as 10, and then n is 10 and p is 0.1, and you'll get the answer. But that's not most calculators. Most calculators don't have that option, and we actually need to rewrite this in a way that they can solve, which is when we have H, in this case, is less than or equal to something. They can't calculate things when it's greater than or equal to, it has to be less than or equal to. And so if we were to rewrite this as something to do with the probability of H being less than or equal to something, we can actually write it as 1, because this is the biggest probability that we can get. 1 take away the probability of H being less than or equal to 3. Because that would give us the probability of H being greater than or equal to 4. Because this probability of H being less than or equal to 3 kind of excludes all probabilities lower than H is greater than or equal to 4. So now we have something in this form. Many calculators now with a binomial distribution option can calculate this. So if we were to put this in our calculator, we'd find that the probability of H being less than or equal to 3 is 0.9872, which we can then do this calculation to find is equal to 0.0128, and this is all to 4 decimal places. And this is our answer. However, there's actually one more way we can do this if we don't have a calculator that can do a question like this, or it's just an alternative method, and that is using the binomial distribution tables that you can read values off of. And if you were to look at one of these tables, which are often in formula booklets, if this was an exam, if we look at when n is 10, p is 0.1, x, which is this value here, it's normally called x, is 3. And then if we read that off of a table, we'll find this value here, 0.9872, and then we can do this calculation, 1 take away that to get our answer. And so we conclude that therefore the probability of H being greater than or equal to 4 is equal to 0.0128 to 4 decimal places. And now this will get us the 1 mark, and the mark is awarded for finding that the probability is equal to 0.0128, which we've found here. For each child, the random variable f represents the number of the throw on which the dart first hits the target. Using Peter's assumptions about this experiment, Part C asks us to find the probability that f is equal to 5. So what this question is essentially asking us is it's asking us to find the probability that the child first hits the target on their 5th throw. And what this therefore implies is that on the child's 1st, 2nd, 3rd and 4th throw, they miss. And then finally on the 5th throw, they hit the target. And so another thing we can say is the fact that the probability that the dart hits the target is 0.1, as we were told up here. If that probability is 0.1, then the probability of missing must be 0.9, because 1 take away 0.1 is 0.9. So if the probability of missing is 0.9, and at first the child misses 4 times, we can say that the probability that they first hit the target on their 5th throw is equal to the fact that they miss 4 times before finally hitting the target. And in terms of probability, we can write that as 0.9 times 0.9 times 0.9 times 0.9, which is 0.9 to the power of 4. And that's the first 4 times where the child misses the target. So that's the probability of that, as we just multiply each probability with each other. And then finally, on their 5th throw, they hit the target, and the probability of that happening is 0.1. So we multiply this by 0.1. And then we find that to 4 decimal places, this is equal to 0.0656. And this is the probability that the child first hits the target on their 5th throw. Now, this question is worth 2 marks, and the first mark of this question comes from finding that the equation for this probability is 0.9 to the power of 4 times by 0.1. So this gets us our first method mark. And then lastly, we get an answer mark for finding that this probability is equal to 0.0656. Thomas assumes that in this experiment, no child will need more than 10 throws for the dart to hit the target for the first time. He models the probability that f is equal to n as equal to 0.01 plus n minus 1 times by alpha, where alpha is a constant. Part D is now asking us to find the value of alpha. So the first thing we want to do with this question is think about any way we could kind of set out this information in a bit of an easier to manage way. And one way we can do this is with a table. So if we draw out a table that shows all the different values of n, and therefore the probability that f is equal to n, it might be a bit easier to see where this is going. So if we start out, and we don't need to draw out a table for every single value of n, if we just do 1, 2, and then 10, this should be enough. So when n is equal to 1, we have 0.01 plus 1 minus 1, which is 0. So this is just the probability that f is equal to n is just 0.01. Now, when n is 2, we have 0.01 plus 2 minus 1, which is 1, times alpha. So we're left with 0.01 plus alpha. And now we'll have a pattern that just follows all of this, and there's no point really writing out all of them. So if we just put some ellipses to show the rest of the numbers. And then when n is 10, which is the biggest number that n can be, because Thomas assumed that the child will need no more than 10 throws, so 10 is the maximum value n can be, we have 0.01 again, plus 10 take away 1, which is 9, times by alpha. So we have 0.01 plus 9 alpha. And so this is our table here. And now we can see that all the values here, and including all of these ones here, all the way up to n, should be equal, when added together, should be equal to 1, because all probabilities should add up to 1 of the same kind of model. And so 0.01 plus 0.01 plus alpha plus etc. plus this should be equal to 1. And so we can see that this forms a series, almost an arithmetic series. And so if we could find the sum of this series, we would know that it must be equal to 1. So the general equation for the sum of the first n terms of a series is that n over 2 multiplied by 2a plus n minus 1d is the sum, where n is these numbers up here, the nth term, a is the first value in the series, and d is the difference between each one. So if we put this into context of ours, we want the sum of the first 10 terms, where n is 10, So we want 10 over 2 multiplied by 2a, and a, the first term, is 0.01, because that's what we have here. And then, again, n is 10, so n minus 1 is 9. And d is alpha, because we can see that each time, and we'd see this if we worked out all of these as well, that each time we add an alpha to the probability. So the difference between each one is alpha. So this is our equation, which we can more simply write as 5 multiplied by 0.02 plus 9 alpha. And as we said before, this must be equal, therefore, to 1, because all of these add up to 1, and this is just an equation to show how we can add all of these up. Now, if we simplify this out a little bit further, we're left with 0.1 plus 45 alpha is equal to 1. So if we take away 0.1 from both sides, we have 45 alpha is equal to 0.9. And then if we divide both sides by 45, we're left with our final answer, which is that alpha is equal to 0.02. Now, this question has 4 marks available, and our first mark is a method mark, and it actually comes from drawing out this table. So kind of presenting this information in this table format gets us our first method mark, and kind of showing the distribution of f. Now, secondly, we get 2 marks for finding the sum of the probability is equal to 1. And the reason for this is we get a method mark just for kind of attempting to do it, and then we get an answer mark for doing it correctly. So doing all of this is equal to 2 marks, a method mark and answer mark. And finally, we get our last mark as an answer mark, and that's just for finding that alpha is therefore equal to 0.02. For part E, we're now asked to use Thomas's model and find the probability that f is equal to 5. So all we need to do for this question is, in this formula up here, we just need to replace n with 5, because we're finding out what happens when the child hits the target on their 5th row, when n is 5. So all we need to write is that the probability that f is equal to 5 is equal to 0.01 plus n minus 1, where n is 5. So 5 take away 1 is 4. So it's plus 4. And then we found out in part D that alpha is equal to 0.02. So we can replace alpha with 0.02. And if we put this into the calculator, we find that therefore the probability that f is equal to 5 is 0.09. Now, the 1 mark for this question is an answer mark. It comes from just stating that therefore the probability is 0.09. Part F is now asking us to explain how Peter and Thomas's models differ in describing the probability that a dart hits the target in this experiment. So if we think back to part A, we stated that one of the assumptions that we needed to make for Peter's model is that the probability of hitting a target was constant, because she used binomial distribution, and that's just an assumption we have to make. So in Peter's model, the probability that a dart hits the target was constant. However, if we now look at Thomas's model, which we have in front of us here, we can see that as n increases, the probability that a dart hits the target also increases, because if this value here increases, then so does the overall probability. And so this is the difference. Peter's model assumes that the probability of a dart hitting the target remains constant. However, Thomas's model assumes that the probability of hitting a target increases with each throw, with each attempt. Now, this question is worth 1 mark, and the 1 mark comes from stating all of this. The mark scheme is quite specific in what words they want you to use. So using the fact that the probability is constant for Peter's model, those 2 words, probability and constant, are underlined in the mark scheme. They're quite important, that we say that the probability is constant. And then that Thomas's model assumed that the probability increases was another key statement needed. But if you have all of that, we get the 1 mark available for the question. Charlie is studying the time it takes members of his company to travel to the office. He stands by the door to the office from 8:40 to 8:50 one morning, and asks workers, as they arrive, how long their journey was. Part A asks, state the sampling method that Charlie used. So we know, as we're told in this piece of information, Charlie waited by the door for the opportunity to ask people how long their journey was. He asked the people who happened to be there at the right time. He didn't pre-plan anything or select the sample carefully based on who people were. He asked who was convenient, who happened to be there between that time frame, 8:40 to 8:50. And so we know that the sampling method Charlie used was something called opportunity sampling, or it's also called convenience sampling. He picked the people who were there when it was convenient at the time that he was there. And this is just a method of sampling where you take the sample from people who are available at the time that the study is carried out and who fit the criteria looking for. So the people who were there from 8:40 to 8:50 this particular morning and who were workers arriving to the office. So all we need to state is that Charlie used opportunity sampling, and this will get us the 1 mark available for the question. We just needed to state opportunity sampling. We could have also called it convenience sampling. They mean the exact same thing, it's just a different name for the same type of sampling method. Now we're asked for part B to state and briefly describe an alternative method of non-random sampling that Charlie could have used to obtain a sample of 40 workers. So of the non-random sampling methods that we know, one of them is opportunity or convenience sampling, but we're being asked for an alternative method, so we can't say that. And the other method that we know is quota sampling, which is where you split the population into different groups based on its characteristics, and then you fill these quotas accordingly. So in this context, we could split it into, for example, men and women, and we could have a quota of 20 men and 20 women workers, and Charlie picks the first 20 men that come into the office and the first 20 women and asks them the question of how long their journey was. But that's not all he could split it into. We could split it into the departments they work at, how old they are, how far they travelled even. And this would be a method of quota sampling. And any of these will get us a mark. Any of the things such as departments, gender, age, this would all get us a mark as a description of the method. So, for example, we could say Charlie could ask 20 women and 20 men how long their journey was. And this will get us both marks for the question. The first mark comes from stating quota sampling. This is the method of non-random sampling to use. So this gets us our first mark. And then the second mark, as I mentioned previously, can come from lots of different things. For example, splitting into women and men. But the mark scheme gives lots of different answers, such as time slots, departments, and the specific example given in the mark scheme is that Charlie would take 4 people every 10 minutes as a way of doing quota sampling. But any of these would get you the second mark to get both marks for this question. Taruni decided to ask every member of the company the time, X minutes, it takes them to travel to the office. Part C asks us to state the data selection process that Taruni used. So what this is telling us is that Taruni asked every single person who works at this company, and the data selection process where you measure or observe every member of the population being here, just everyone who works at the company. The data selection process where you observe everyone is known as a census, and this is all we have to say, that Taruni used a census as their data selection process. And this will get us the 1 mark for the question. This was all we needed to state for the 1 mark. Taruni's results are summarised by the box plot and summary statistics below, where we can see this diagram, and N is 95, so the amount of people that they asked was 95 people. The sum of X is 4,133, and the sum of X squared is 202,294. And part D wants us to write down the interquartile range for this data. Now if we look back at this box plot, if we're asked for the interquartile range, what this is it's the upper quartile take away the lower quartile. And on a box plot diagram, the upper quartile is this line here, and the lower quartile is this line here. So it's kind of the top and the bottom of the box itself. So in this case, the interquartile range is this value here, which if we read off the diagram is 58, and the lower quartile, if we read off down here, is 26. So the interquartile range is 58 take away 26, which is equal to 32, and that's our interquartile range. And this gets us 1 mark, and the mark comes from the answer, so it's an answer mark for stating 32, or 32 minutes if we wanted to add on the units. Now part E wants us to calculate the mean and the standard deviation for this data. So if we start out with calculating the mean, the general equation is that x bar, or the mean, is equal to the sum of x, which we can denote with this sigma x, divided by n. So in the context of this question, we've been given both of these values here. So we can say that the sum of x is 4,133, and this is divided by 95. And so the mean of this data is 43.5, and this is to 3 significant figures. Now, second of all, to calculate the standard deviation, one way we can write the formula, because there are different ways that we can actually write this formula, but one way we can write it is that standard deviation of this data is equal to the square root of sigma x, so the sum of x squared over n, take away the sum of x over n, so the mean, squared. And so if we were to write this with the data that we've been given, we know it's equal to the square root of 202,294 over 95, take away the mean, which we just found out is 4,133 over 95. Remember, we need to use its whole value, not just 3SF, because we'd get the wrong answer. And then if we put this into the calculator, we find that the standard deviation of this data is equal to 15.4 to 3 significant figures. And this is all we need to do for the 3 marks available for the question. First of all, we get a mark for finding the mean, so 1 mark for all of this, including the answer. And then we get a method mark for doing the standard deviation calculation, which is what we've done here. And then we get an answer mark for doing this correctly and getting that it's equal to 15.4. Part F is now asking us to state, given your reason, whether you would recommend using the mean and standard deviation or the median and interquartile range to describe this data. So if we look back up at the box plot, we can see that these 2 stars here are quite far away from the rest of the data. And what these are outliers. And what an outlier is something that doesn't really conform to the rest of the data. And essentially, it's kind of affects the mean and standard deviation because these take account of all of the data. And the problem with outliers being included in the mean and standard deviation is that they can maybe make this data larger than it should really be according to the rest of the data, because the outliers are just so different from the rest of the journey times in this case. And so because of this, we can say that we can recommend using the median and interquartile range to describe this data, as opposed to the mean and standard deviation, because the median and interquartile range aren't affected by these outliers. We can see that they're just here, and the interquartile range being this take away this, and they're not affected by anything so far away like the outliers, whereas the mean and standard deviation takes account of all of the data, which in this case may end up becoming a problem as it's taking into account these outliers. So there are 2 marks available for this question, And the first mark comes from acknowledging the fact that there are outliers in the data, and therefore that these are a problem for the mean and the standard deviation. So this is our first mark, and therefore, as our second mark, that we should use the median and the interquartile range. So this is 2 marks for kind of stating all of that in this one sentence. Rana and David both work for the company and have both moved house since Taruni collected her data. Rana's journey to work has changed from 75 minutes to 35 minutes, and David's journey to work has changed from 60 minutes to 33 minutes. Taruni drew her box plot again and only had to change 2 values. Part G asks, explain which 2 values Taruni must have changed and whether each of these values has increased or decreased. So if we were to mark on this box plot these changes in journey time, so Rana's journey changed from 75 minutes to 35 minutes, so they went from here, around 75 minutes, all the way down to here, 35 minutes. So they came from here to here, and David went from 60 minutes, which is here, to 33 minutes, which is around here. And so they went from here to here. So you can see the common thread with these 2 changes in journey time is that they both went from being above the upper quartile to below the median. What this means is that now, since there are more values in this space and less values in this space, the median must decrease because the median journey time, there's two values have now moved to lower than they were before, so the median journey time must also decrease with that, kind of following this trend, and therefore so will the upper quartile. So since there are more values that have moved into this kind of lower area, on the lower end of the journey times, then the median and the upper quartile must also decrease to kind of go with that. And so we can write out that the median and the upper quartile will both change, and these are the only things that will change, due to more values being less than 40, which is the median. And since there are now more values less than this, the median will decrease, kind of to follow this trend, and so will the upper quartile. And now there are 3 marks available for this question. And we get a first mark for stating that the median and the upper quartile are the values that will change, which is what we've done kind of up here. We also could have done it in reverse and stated what will not change, by saying that the outliers, the lower quartile, and these values at 20 and 92 won't change. But we can also say that the median and the upper quartile will change. And then we also have to state that this is because there are now more values below 40 than there were previously above it, which is what we've written around about here. And finally, therefore, the median and the upper quartile will decrease, gets us our 3rd mark. The lifetime, L hours, of a battery has normal distribution with mean 18 hours and standard deviation 4 hours. Alice's calculator requires 4 batteries and will stop working when any one battery reaches the end of its lifetime. Part A wants us to find the probability that a random selected battery will last for longer than 16 hours. So first of all, if we look back to the start of the question, where we're told that the lifetime has normal distribution with mean 18 hours and standard deviation 4 hours, if we were to write this out kind of in the way we write out normal distribution models, we say that the lifetime has a normal distribution, and then we normally do mu sigma, where mu is the mean, so in this case 18 hours, and then it's sigma squared, and sigma represents standard deviation, so we'd write 4 squared. So this is how we'd write it out, kind of in the format that we write out normal distribution. So now we have this written out. We want to find the probability that a randomly selected battery will last for longer than 16 hours. And since the lifetime is represented with L, we want to find the probability that the lifetime L is greater
than 16, the lifetime will last for longer than 16 hours. And that's how we can write that in terms of probability. So if we want to find the probability that L is greater than 16, if we, on our calculator, go to the distribution, normal distribution section, and then this is normal CD, because we have an inequality. And we now put in that the lower bound is 16, because the minimum value this can take is 16. And the reason it's not maybe 17, because it's greater than and not greater than or equal to, is because with normal distribution, it's continuous data. We can say that L being greater than 16 and L being greater than or equal to 16, kind of the same thing, and we can calculate them in the same way. So the lower bound is 16, because that's the smallest that the lifetime can be. And then the upper value, the upper bound, we just put as a big number. They say to do minimum 5 standard deviations above the mean, which here would be 5 times 4 is 20, so 20 plus 18. So the minimum that you could set your upper bound here should really be 38, but you can put any number. You could put 50, 100, and it would give you the same answer each time. So if we put the upper bound as 100, just because it's easy, sigma is 4, because it's the standard deviation here is 4 hours, we've been told this. And then mu is 18 hours, this mean of 18 hours. And if we put this all in to a calculator, to 3 decimal places, or to 3 significant figures, we should get that the probability that L is greater than 16 is 0.691. And that's 3 SF. And now there's one mark available for this question, and it's a mark that comes from getting the answer right. So saying that the probability that L is greater than 16 is 0.691 will get us 1 mark.
At the start of her exams, Alice puts 4 new batteries in her calculator. She's used her calculator for 16 hours, but has another 4 hours of exams to sit. Part B asks, find the probability that her calculator will not stop working for Alice's remaining exams. So what this question is essentially asking, if we put it into kind of different terms, is it's asking for the probability that her calculator will last 20 hours, 16 plus 4, given that it's already lasted 16 hours. And it's important that we think of this given that, because in probability, this can be written as the probability that the lifetime of the calculator is greater than 20, it lasts for more than 20 hours, and then we write given that as this kind of straight line, and this does affect the calculation. So given that the lifetime is already lasted 16 hours. And then the other way that this can be written, so what this means, is the probability that the lifetime lasts 20 hours divided by the probability that it's lasted 16 hours. So if we use the normal distribution function on the calculator, when we do normal CD, because this is an inequality, if we set the lower bound as 20, the upper bound as any number that's greater than 5 standard deviations above this, so we could just do 100, and then the standard deviation is 4, and the mean is 18. These are both things we're told in the start of the question. If we do all this, then we find that the probability that L is greater than 20 is if we write everything to 4 decimal places, in the real calculation, obviously use all possible decimal places we're given, but just to write it down. The probability that L is greater than 20 is 0.3085, etc. And we found in part A the probability that L is greater than 16, and we found that to be 0.6915 if we do this again to 4 decimal places. And so if we do this calculation, we find that the probability that L is greater than 20 given that L is greater than 16 is equal to 0.4462, and that's to 4 decimal places. However, this is the probability that one battery will not stop working for this 20 hours, given that it's lasted for 16. But we know that Alice's calculator requires 4 batteries. And so to find the probability that all 4 batteries will not stop working, we need to multiply the probability by itself 4 times, 1 for each battery. And so the way we can write this is 0.4462 to the power of 4. And this is equal to 0.0396. And that's to 4 decimal places. And therefore, this is the probability that the calculator won't stop working for Alice's remaining exams, because this is the probability that each battery won't stop working, not just one battery, all 4. Now, this question is worth 5 marks, and the first mark is a method mark for stating this, so stating that we need to find the probability that L is greater than 20, given that L is greater than 16, and then writing it in this kind of division format. And then we get a further answer mark for doing this calculation here, so finding that the probability of L over 20 divided by the probability of L over 16 is equal to this, to 0.4462. And we actually get 2 answer marks for this. One for this kind of ratio of probabilities, and this for the actual answer. And then we get our last 2 marks from this. So one as a method mark for doing 0.4462 to the power of 4, and then a further answer mark for finding that the answer to this question is 0.0396 to 4 decimal places. Alice only has 2 new batteries, so after the first 16 hours of her exams, although her calculator is still working, she randomly selects 2 of the batteries from her calculator and replaces these with the 2 new batteries. Part C wants us to show that the probability that her calculator will not stop working for the remainder of her exams is 0.199 to 3 significant figures. So what this question is telling us is that in the last 4 hours of Alice's exams, her calculator is going to have 2 new batteries in them, and 2 batteries that have already lasted 16 hours. And we want to find the probability that they'll last another 4 hours, given that they've already lasted 16. So if we start off with the 2 new batteries, if they're new, these batteries only need to work for 4 hours to keep the calculator going, which is different to the others, which need to have lasted 20 hours in total. So if these batteries need to last 4 hours each, the probability of that is that the probability of their lifetime being greater than 4, because that's all we need for Alice to finish her exams, that they last more than 4 hours. So if this is for 1 battery, then for 2 batteries, because there are 2 new batteries, if the probability of each is that the lifetime is greater than 4, then we just need to multiply that again for the other battery, which we can also write as it being squared. So this is the 2 new batteries, because they each need to last for longer than 4 hours. L, the lifetime, needs to be more than 4 hours. So if this is for the 2 new batteries, now what about the 2 old ones that have already lasted 16 hours? So in part B, we needed to find the probability that the calculator will not stop working for the rest of her exams when all 4 have already lasted for 16 hours. And what we needed to find was the probability that the lifetime is greater than 20, given that the lifetime is greater than 16, so given that it's already lasted 16 hours. And that found us the probability for 1 battery that this will happen. And then we needed to do that to the power of 4 to find all 4 batteries. But here, we only have 2 batteries that need to do this. So we only need 2 batteries to last for 20 hours, given that they have lasted 16. So if we multiply the probability for the 2 new batteries by the probability that they will last for greater than 20 hours, given that, which we represent with the straight line, given that they've lasted for longer than 16 hours. And then because there are 2 batteries that need to do this, we square it. And this is how we'd find the total probability, because this is for all 4 batteries. This is for the 2 new batteries, and this is for the 2 that have already been in the calculator for 16 hours.
So now if we substitute in this with numbers, if we use the normal CD distribution function on our calculator, we find that the probability that the lifetime is greater than 4 is equal to 0.9998, and that's to 4 decimal places. We need to use the whole answer in our calculations, but just for writing down, if we do it to 4 decimal places. And then, as we found in part B, the probability that L is greater than 20, given that L is greater than 16, it is equal to 0.4462, again to 4 decimal places, squared. And now if we do this calculation, we find that the total of this is equal to 0.199, and that's to 3 significant figures. And this is the answer that we wanted to find. We wanted to show that it was equal to 0.199, and we've done that because this is the probability for each of the 4 batteries multiplied together. So this question is worth 3 marks, and first of all we get a method mark, and that's for writing out this, so kind of showing what probabilities we need to find and what we're going to then do to them, which in this case is square them all. So this gets us a method mark for just attempting to do this. And then we get an answer mark for finding the probability that L is greater than 4, and then using the probability that L is greater than 20, given that L is greater than 16, which is what we've done in this line here. So finding this value and correctly substituting this value from part B gets us a further answer mark. And then finally we get an answer mark for showing that this probability is therefore equal to 0.199 to 3 significant figures, which is what we were asked to do in the question. After her exams, Alice believed that the lifetime of the batteries was more than 18 hours. She took a random sample of 20 of these batteries and found that their mean lifetime was 19.2 hours. Part D asks, stating your hypotheses clearly and using a 5% level of significance, test Alice's belief. So the first thing we do in hypothesis testing, and as we've been told to do at the start of the question, which is to state our hypotheses clearly. What this means is we need to say what our null hypothesis and our alternative hypothesis is. Now, the null hypothesis, which we write as H0, is that the mean is equal to 18. This is what we were told right up at the start of the question, and this is what Alice is challenging. So the null hypothesis is that this is true. However, the alternative hypothesis, which is what Alice is claiming, is that the mean is greater than 18, because Alice believes that the mean is now 19.2, as this is what she's found with her sample that she took. And therefore, the alternative hypothesis is that this isn't true, and that the mean is actually greater than 18. So we know, as a general kind of equation, we can write, if I put it to the side here, that the random if x is the random variable, that the sample mean, we write as x with a bar over it, is normally distributed, and then we write it as mu, so the mean, comma, and then standard deviation squared, which is also called variance, divided by n, where n is the sample size. So in this case, for example, Alice took a sample of 20, so our n would be 20. But as a general equation, this is how we find how the sample mean x bar is normally distributed. So if we apply this to the context of our question, our random variable is called L, lifetime. So we would write that L bar is normally distributed, where mu, the mean, is 18, as we were told at the start of the question. And now here, we know that the standard deviation is 4. So we have 4 squared over n, which is 20. So as this is our sample size that Alice took. So this is how we would write it kind of in this format. And so what we do now is, firstly, it would be worth writing the standard deviation squared over n as a number squared. And the reason for that is for later in calculations. When we use the normal distribution function on a calculator,
we have to put in the standard deviation, but this number, kind of the thing after the comma in these brackets, is always standard deviation squared, and it's important not to get that mixed up, because this will change your answer if you just put in whatever this is as the standard deviation. So if we write it a little bit differently, just that L bar is normally distributed with mu equals 18, and then this is just written as 4 over root 20 squared. If we just kind of square root the top and the bottom and take that power to the outside of the brackets, we now have a standard deviation squared. So this is the standard deviation that we would use in our calculator when doing this calculation. So now we want to find the probability that this L bar is greater than 19.2 hours, because this is what Alice found their mean lifetime to be. So we want to see if this sample mean is greater than what Alice said, which was 19.2 hours. And we want to find the probability of that. So if we find the probability that this L bar is greater than 19.2, and then we put this into our calculators using the normal distribution function, we set the lower bound to 19.2, the upper bound to just any number greater than 5 standard deviations above this. So we could just put 100, 1,000, it doesn't really matter as long as it's quite a big number. The standard deviation, and this is the important bit, it is not this whole value, it's just the 4 over root 20, which is about 0.8944, that's to 4 decimal places, and then mu is 18. So if we put that all in, we find that the probability that L bar is greater than 19.2 is equal to 0.0899, and that's to 4 decimal places. And so this is the probability that this sample mean is greater than 19.2 hours. Now, if we compare this to the level of significance we were told to use, we were told to use a 5% level of significance, which as a decimal is 0.05. So if we compare this answer we got to this level of significance, we can say that the probability that L bar is greater than 19.2 is actually greater than 0.05. It's greater than the level of significance. And therefore, we have to say that there is not enough evidence to reject HO, and therefore there's not enough evidence to support Alice's belief, because if there isn't enough to reject HO, and HO is the assumption that the mean is equal to 18, which is not what Alice said, so there's not enough evidence to say that we can accept this alternative hypothesis here. And now this question is worth 5 marks, and firstly we get a mark for stating our hypothesis clearly, as we were told to do in the question. So stating what H0 and H1 are, which we've done over here, gets us our first mark. And now secondly, we get a method mark for writing out this whole equation, or in this form. The mark scheme actually has it just straight in this form, but they mean the exact same thing. So doing this gets us a method mark. And then we get an answer mark for finding the probability that L bar is greater than 19.2 and finding what that's equal to, which is 0.0899 to 4 decimal places. And finally, we get 2 answer marks for these last 2 sentences, because we get one for saying we can't reject H0, so kind of giving a non-contextual answer. So this is just generally looking at the maths, we can't reject H0. And then we get a further answer mark for putting it into the context of the question and saying, well, therefore, there's not enough evidence to support what Alice was saying, and we can't support her belief. And that's our last answer mark, so putting it into context. And that's all 5 marks. At time t seconds, where t is greater than or equal to 0, a particle p moves in the xy plane in such a way that its velocity, v meters per second, is given by v equals t to the power of minus a half I minus 4tj. When t is equal to 1, p is at the point A, and when t equals 4, p is at the point B. Find the exact distance AB. So we know that we need to find a distance, that's stated quite clearly in the question, and we have been given a velocity. And now the way to get from velocity to distance, or rather displacement, is through integration, because we know, as a general rule, that velocity is equal to the differential of displacement, and therefore displacement is equal to the integral of velocity. And since we want to find displacement so we can then find distance, we need to use this rule. So if displacement is equal to the integral of velocity, and we know that in this case, velocity is t to the power of minus a half I minus 4tj by dt, then we can solve this. So first of all, if we start off with t to the power of minus a half I, when we integrate, we add 1 to the power, so add 1 to minus a half gives us a half, and then we divide the number in front of the t by this, so which is just 1. So 1 divided by a half is 2. So we put this now as the coefficient of t and keep the power as the previous one plus 1. And then we just add the I. The i's and the j's don't change when we integrate and differentiate vectors. So now if we do the same thing with minus 4tj, we add 1 to the power, we have t squared, and divide minus 4 by 2, we get minus 2t squared j. And then because this is indefinite integration, we need to add a c, which is a vector in this case. So it has an I component and a j component, we just don't know what it is. So now, we're also told in the question that when t is equal to 1, p is at A, and when t is equal to 4, p is at B. So if we want to find the displacement at A, we just need to substitute in t equals 1. So if we do this, 2 times 1 to the power of a half I, minus 2 times 1 squared j, and then plus c, which we still don't know what it is, we find that an expression for the displacement at A is 2I minus 2j plus c. And now if we do the exact same thing for B, we know that at B, t is equal to 4. So if we substitute in t equals 4, we have 2 multiplied by 4 to the power of a half I minus 2 multiplied by 4 squared j, again plus c. And this is equal to 4I minus 32j plus c again. So now that we have an expression for the displacement at A and B, we can try and find the distance AB. And the way we do that is if we visualise these two displacements as points, so in the xy plane, as we're told right up here, if we drew A as coordinates, we know that if this was the origin, so this is when I and j are both 0, we know that A is 2I, which is 2 in this positive I direction, minus 2j, which is downwards. So A is around here, and B is 4I, so it's further along, and minus 32j, so it's much further down. So this really isn't in perspective, but if we say that B is here, then we know that if the coordinates of A here are being drawn as 2 minus 2 relative to this origin, and for B they're drawn as 4 minus 32, then we can find this distance AB using Pythagoras, because we can make a right-angled triangle here between these 2 points. And the reason we don't need to include C, because we do have a C in both of these, is that to find the difference between these 2 points, so finding this distance and finding this distance, we will have the 2 C's cancelling out because we'll have C take away C. So we can kind of almost ignore the C because they end up cancelling out. So if we now go to find this distance here and this one here, so we can do Pythagoras, just take the difference of the x coordinates in this case, where the x coordinates are 2 for A and 4 for B. So if this distance here is 4 take away 2, we know that this distance here is just 2. And if we use the exact same principle for this distance, we know that the y coordinate here is minus 2, and here it's minus 32. So if we do minus 32 take away minus 2, which is minus 32 plus 2, we get that this is minus 30, but as it's a distance, we can just say that it's 30. So now that we know the distance of this horizontal and vertical lines, we can use Pythagoras' theorem to find AB. So we know that AB is equal to the square root of 2 squared plus 30 squared. And so if we solve this, we find that this is equal to the square root of 904. And then if we just simplify that, this can also be written as 2 root 226. And this is meters because this is a distance. And if we also remember that the question is asking us for the exact distance. So exact means leave it in this surd form, don't give it as a decimal to 3 significant figures or something, because that isn't exact. And so you wouldn't get the mark for this. So this question is worth 6 marks. And our first mark comes from integrating the velocity with respect to time. So this gets us a method mark, and then we get a further answer mark for doing it correctly and finding that the displacement is 2t to the power of a half I minus 2t squared j plus c. We get another method mark for substituting t equals 4 and t equals 1 respectively. So for doing this and for doing this gets us 1 mark for both of them. So if we just put it as here. And then this gets another answer mark for doing it correctly. So finding these two formulas gets us another 1 mark as an answer mark. And now we get another method mark for then using Pythagoras' theorem to find the distance AB. So doing this calculation gets us a method mark. And then lastly, we get an answer mark for finding that the distance AB is equal to 2 root 226 meters. A wooden crate of mass 20 kilograms is pulled in a straight line along a rough horizontal floor using a handle attached to the crate. The handle is inclined at an angle alpha to the floor, as shown in figure 1, where tan alpha is equal to 3 over 4. The tension in the handle is 40 newtons. The coefficient of friction between the crate and the floor is 0.14. The crate is modelled as a particle, and the handle is modelled as a light rod. Using the model, Part A asks us to find the acceleration of the crate. So, first of all, since we've been given all this information, it might be best if we can try and visualise it a bit better by marking it on the diagram. So, first of all, if we know that the crate has a mass of 20 kilograms, we know that it must therefore have a weight of 20g, since F, force, which in this case is weight, is equal to mass times acceleration. The mass is 20 kilograms, and the acceleration is gravitational acceleration, which acts downwards, and we can call this g. So we have a weight, and therefore we must also have a reaction force. This acts perpendicular to the plane, and if we just call it r, we don't know what it is, but we know it acts in this direction. We're also told that there's a coefficient of friction and that the floor is rough, which both tells us that there is a frictional force, and if the crate is moving in this direction, in the direction of this arrow, then the frictional force must act against that. So if we say that it acts in this direction, and if we just call it F for now, again, we do not know it just yet. And now the final thing that we can mark on this diagram is this 40 Newton force, this tension in the handle. It might be easier for further calculations if we componentize it into a vertical and a horizontal component, because given that this arrow, and this arrow are all acting either vertically or horizontally, all our calculations are going to be
in these two planes, and so it would be best if we can also write this force in these two planes. So if we start with vertically, if we were to use trigonometry, this is a right angle triangle. The hypotenuse is this, and it has a value of 40, and the angle is alpha. So if we're using the opposite in the hypotenuse, this is the sine rule, where sine alpha is equal to opposite over 40. If we rearrange that, we know that the value of this component is 40 sine alpha. And if we do the exact same thing with this horizontal component that acts in the same direction that this arrow does, we now need the cosine rule. And so here it would be 40 cos alpha, using the same principles we did for this vertical component. So now that we've got all of this information a bit more easy to visualize on our diagram, we can start to try and find out some of these values. So the first value that we don't know is this reaction force, R. So if we went to find this, if we were to resolve in the direction that R acts, which is vertically upwards, we resolve vertically upwards. This is using the equation F equals ma. So if we start with the forces, the left-hand side, we know that the force is acting in the direction of R are this force here, which is R, and also this component of the tension acts upwards, 40 sine alpha. So we know that acting in this positive direction is R plus 40 sine alpha. However, we also have a force that's acting against this, and we could say this is in the negative direction if we're resolving upwards, and that's this 20g, the weight of the crate. So we could write this as take away 20g, and that's now the kind of net forces if we're resolving upwards. Now force is equal to mass. We know that the mass is 20, but we know that the acceleration when we're resolving upwards is 0. The crate isn't moving upwards, and so it's not accelerating upwards. And so 20 times 0 is 0. So we know that this is all equal to 0. And so we can see that now, in our equation, resolving upwards, we have two unknowns, because we have an r, but we also have an alpha, and we need to find what one of these are before we can solve the equation. Now, in the question, we were told that tan alpha is equal to 3 over 4. And what that means is we can draw a right angle triangle to represent this. So if we drew a triangle like this, where this is the right angle, and if we just call this angle alpha, it doesn't really matter which of these two angles we call alpha. If tan of alpha, in general, is equal to the opposite over the adjacent, and we've been told here that it's equal to 3 over 4, this means that the opposite must be 3 and the adjacent 4, because here we can see that tan alpha would be equal to 3 over 4, which is what we've been told. So using this, we can now use Pythagoras' theorem to find this final missing side of the triangle. We know that the square root of 3 squared plus 4 squared is equal to 5, so that this is now 5, and so we have a full right angle triangle, and from this we can use trigonometry to find a value for sine alpha and cos alpha, as well as tan alpha, which we already have. So if we start out with the one we know, tan alpha is equal to opposite over adjacent, which here is 3 over 4, which we have been told, but it's kind of a check of whether we've done this correctly, since we've got the same as the question. Now, sine alpha is opposite over hypotenuse, and here we can see that the opposite to this angle alpha is 3, and the hypotenuse is 5, so sine alpha is equal to 3 over 5. And lastly, cos theta is adjacent over hypotenuse. Adjacent here is 4, hypotenuse is 5, so cos alpha is 4 over 5. So now we have values for all of these. We can substitute in to this equation where we have 40 sine alpha. We can substitute in that sine alpha is equal to 3 over 5. And then, if we were to do this, we'd end up with r plus 24 take away 20g is equal to 0. So now, if we were to rearrange this to get r as the subject, we would add 20g to both sides and take away 24. And if we did this and then solved it in a calculator where g is 9.8,
we would find that R is equal to 172 newtons. So this reaction force here is 172 newtons. So now that we've found this, we can actually go on to finding the acceleration of the crate. And the reason for that is because of the equation that states that the frictional force is equal to the coefficient of friction multiplied by the reaction force. And so we know that this frictional force here we don't have a value for, so this is just F. However, we were told in the question that the coefficient of friction between the crate and the floor is 0.14. So we know that the coefficient of friction is 0.14, which we represent with a mu in the formula. And then this is multiplied by R, which is this force here, and the one that we just found to be 172. So we know that the frictional force is equal to 0.14 multiplied by 172. And so we can actually find this frictional force. If we do this calculation, we find that the frictional force is equal to 24.08 newtons. And so now we have a value for all of the previously unknown things in this diagram. We have R, we have F, and we found a way that we can solve things with alpha in them because we have equations for cos and sine alpha. So now that we have this, we can find acceleration because we can make an equation and solve it. So since the crate is moving this way, it's moving horizontally along the floor, that means this must be the direction of the acceleration. And therefore, we would resolve in this direction, which is horizontally to the right on the screen. And so again, using F equals ma like we did before, we know that the forces acting in this direction, if we went back to the diagram, the forces acting in this direction positively are 40 cos alpha. That's the only force that acts in that direction. And then the forces acting against this direction, there's only one again, and that's this one, F, that's acting in the negative direction when we resolve to the right. So we can write the forces, so on the left-hand side, we would write this as 40 cos alpha, and then take away F, which we've just found to be 24.08, but if we write it as F at the moment, so take away F. So this is the net forces when we resolve in the direction, this arrow here. And now this is equal to the mass of the crate is 20, and then the acceleration is what we're trying to find, so if we just leave that as A, because this is what we're solving for. So now we know that cos alpha is equivalent to 4/5, as this is what we've found up here at the top of our workings out. So we can rewrite 40 cos alpha as 40 multiplied by 4/5, and this is equal to 32. So we have 32 take away 24.08 equals 20A. And so if we do this calculation, just 32 take away 24.08, 28 is equal to 7.92. And then when we divide by 20, we can find that the acceleration is equal to 0.396. And then acceleration is measured in meters per second squared. And this is our final answer. We found the acceleration of the crate is 0.396. So this question is worth 6 marks, and we get our first 2 marks come grouped together, and they come from resolving vertically. So that's this first thing we've done here, resolving vertically upwards. And the reason we get 2 marks for this is we get a method mark for simply doing it, so just for resolving vertically, regardless of the answer that we then ended up with, we get a method mark. And then we get a further answer mark for doing it correctly, and ending up with this expression up here. So this is 2 marks, a method, and an answer mark. And then we get a further 2 marks for doing the exact same thing,
horizontally. So attempting to resolve horizontally gets us a method mark, and then doing it correctly gets us an answer mark, which is what we've done here. So that's another 2 marks. We also get a mark for finding the frictional force, so knowing that the equation is the frictional force is equal to the coefficient of friction times the reaction force, and then knowing that what the coefficient of friction is and the reaction force, and solving that. So this gets us a further mark. And lastly, we get an answer mark for finding what the acceleration is. So stating that a is equal to 0.396 meters per second squared gets us the last mark available for this question. The crate is now pushed along the same floor using the handle. The handle is again inclined at the same angle alpha to the floor, and the thrust in the handle is 40 newtons, as shown in figure 2 below. Part B asks us to explain briefly why the acceleration of the crate would now be less than the acceleration of the crate found in Part A. So we can see the difference between figure 1 and figure 2 is that in figure 1, the tension acts outwards in this direction, out and up, whereas in figure 2, the thrust is now acting in towards the crate and it's acting downwards. So if we were to draw onto the diagram its vertical and horizontal components like we did in figure 1, unlike figure 1, its vertical component is now acting downwards instead of upwards. And similarly to figure 1, the horizontal component acts horizontally to the right, so in the same direction, because the crate is still moving in the same direction. It's just that the handle is now in a different position, which affects the components. So in part A, the first thing we did was calculate the reaction force, which is this force acting upwards here, just as it is in figure 1 up here. So the first thing we did was calculate the reaction force, and in figure 1, for the forces in the F equals ma equation, acting upwards we had R and this component of the tension, and then we had the weight acting downwards, whereas if we add the weight on as well. In this figure 2, if we were to do the exact same thing, resolving upwards, we would have R acting in this direction, but then we would have this component and the weight both acting against it, instead of just the weight acting against it and the vertical component acting in the same direction. So now we have less things acting in the same direction as the reaction force. And since it was this is equal to 0, the forces were equal to 0, if there were more things acting in the negative direction when resolving upwards, this would increase R. And if R increases, so does F, because of the equation F equals mu R. An increase in R, where mu is the same, leads to an increase in F. So now our frictional force has increased because of our reaction force increasing. And now if we think back again to A, the formula we used in part A to find the acceleration was the horizontal component of the thrust in this case, but tension in part A. Take away the frictional force is equal to 20 times the acceleration. So we were taking away this frictional force from the horizontal component. So if this frictional force is now increased, we're now going to have a smaller number on this side of the equation, and therefore dividing a smaller number by 20, because it's F equals ma, mass is 20. So if the net value of force when resolving horizontally, if that's decreased, and we divide that by 20, it's going to be a smaller value than what it was in part A, because this net force is decreased due to an increase in the frictional force. And therefore, this will lead to a decrease in the acceleration. So if we were to write that out, we can say that if we pushed the crate along the floor, the reaction force R will increase due to the vertical component of the thrust, this 40 Newton arrow. The vertical component now acts downwards. and therefore this will cause the frictional force to increase, as we said, because of the F equals mu r equation. And if the frictional force increases, the acceleration A will decrease. And this question is worth 2 marks, and we get our first mark for saying that because we push the crate, R, the reaction force, will increase, and this will therefore increase F, the frictional force. So that gets us first mark, if we were to mark it on around here. And then we get our last mark for saying that if we increase F, this will cause A to decrease, so concluding that A will decrease in total. This will get us both marks. Equals 0, the particle is at O, and moving with velocity 2I minus 3j meters per second. At time t equals 2 seconds, P is at the point A with position vector 7I minus 10j meters. Part A wants us to show that the magnitude of the acceleration of P is 2.5 meters per second squared. So the first thing to note that we're told in this question is that the particle P is moving with constant acceleration. And another thing we're told is the velocity of the particle, the position vector of the particle, which we can also call the displacement, and we know that we want to find acceleration. And one way we can do this with all of these terms is to use the constant acceleration formula, and we know we can do that because we're told that acceleration is constant. And so the way we lay out what is also called a Suvat equation is if we list off the terms that we could potentially use, remembering that displacement, velocity and acceleration are all vectors. The displacement S is the position vector, which is 7I minus 10j meters. The initial velocity is 2I minus 3j, again as we're told in the question. The final velocity we don't know, we're not told this anywhere in the question, but we also don't need to know it in terms of this question because we're trying to find acceleration, so we can put a slash there. And the acceleration we also don't know, but this time we want to find the acceleration because that's the purpose of the question. So if we put a question mark to signify this. And last of all, we know that t is 2 because this whole journey, where the displacement is 7I minus 10j, is this journey we're given here between the time 0 and 2 seconds. So in our equation, we now need to have terms for S, U, A and T, and not V. And the one Suvat equation that has this is the equation S is equal to UT plus half AT squared. And now if we substitute in the terms that we have into this equation, we'll end up with 7I minus 10j is equal to 2 multiplied by 2I minus 3j plus a half of A multiplied by 2 squared. And so if we rearrange this a bit, we still have 7I minus 10j on the left hand side, but on our right hand side we now have 4I minus 6j, and then this is plus 2a. So the purpose of this question is to find the magnitude of the acceleration, so we need to rearrange this so it's in terms of acceleration a. So if we do this and try and get all of the I and j terms on one side and the a term on the other side, we can first end up with 2a being equal to 3I minus 4j, and then if we divide both sides by 2, we have the acceleration is equal to 3 over 2I minus 2j. So now we have a term for the acceleration. What we don't have is the magnitude. So this is the acceleration as a vector, but our question wants us to show that the magnitude is 2.5 meters per second squared. So we need this as one single number, a constant. And so the way we can do this is to visualize it on a diagram. So what 3 over 2I minus 2j means is that if we have a starting point, if we call it O, because we know when t is 0, the particle's at O. So at this starting point O, our acceleration is 3 over 2I along, which means that we're moving right by 3 over 2. So if we draw this on, this is 3 over 2 in this direction, and then minus 2j means that we're now moving 2 downwards. So the j axis
is vertical, and so minus 2j is going to be 2 down in this direction. And this will take us to our point A. So when t is 0, p is at this point A here. And we can connect these up, O to A, and this is our acceleration from O to A. And so we can see that this has formed a right angle triangle, and we know that if we wanted to find this length here, which is our magnitude of acceleration, then what we can do is we can use Pythagoras' theorem. So we know that the magnitude of A, which can be written with these modulus signs, the magnitude of A is equal to the square root of 3 over 2 squared plus minus 2 squared, or just plus 2 squared. These are exactly the same because any negative number squared is positive anyway. And then if we solve this, we find that the magnitude of A is equal to 2.5 meters per second squared, which is what we were trying to show in the question in the first place. So we know we've got our question right. Now this question is worth 4 marks, and we get our first mark as a method mark for using this expression s equals ut plus half at squared and substituting in our numbers correctly. And our second mark is an answer mark for finding this expression for the acceleration. Now thirdly, we get a method mark for attempting to find the magnitude of A using Pythagoras. And our last mark is an answer mark for ending up with 2.5 meters per second squared. At the instant when p leaves the point A, the acceleration of p changes, so that p now moves with constant acceleration 4I plus 8.8j meters per second squared. At the instant when p reaches the point B, the direction of motion of p is northeast, and part B wants us to find the time it takes for p to travel from A to B. Now, unfortunately with this question, we can't quite do what we did in part A, where we constructed one Suvat equation, and that was enough to find our answer, the acceleration in that case. But we can't do that here for the reason that we just don't have enough information. We've been given the acceleration between A and B, and we know that the direction of motion is northeast, but this isn't enough to construct a Suvat equation and solve it. So we need to find more information. And the first way we can do this is using the fact that before the particle P travelled to B, it came from point O. So it went from O to A to B. And if we were to draw this on a diagram, where this is the point O, this is A, and this is B, we just kind of assume they travelled in this straight line, we know that at the point O, particle P was travelling with an initial velocity, if we call that u1, and therefore when it got to A, there was a final velocity, v1, and we kind of incorporated that in our Suvat equation for part A. And we can say that the same must be true between A and B. It must leave A with some initial velocity u2, and it must have got to B with a final velocity, if we call that v2. And we can see, looking at this diagram, that above A we have two velocities. We have the final velocity between O and A, and the initial velocity between A and B. And since these are both velocities at the point A, happening at the same time, these velocities must be equal. So the initial velocity between A and B has to be equal to the final velocity between O and A. And we can use that to construct an equation and find the final velocity between O and A, and then incorporate that into an equation between A and B. So if we write out that from O to A, if we do a Suvat equation, we know that first of all, the displacement from O to A is 7I minus 10j, we're told this in the question, and the initial velocity is 2I minus 3j, again, we've been given this information. The final velocity v is what we're trying to find, because we know it's the same as the initial velocity between A and B. The acceleration we've also found in part A, and as a vector, it's 3 over 2I minus 2j. And the time, because we know we're between O and A, and we know this is between time 0 and 2 seconds, we know that the time must be 2 seconds. Now, with all this information, we actually can pick 4 of the 5 constant acceleration formula, any of the ones with v in them, because v is the one thing we need to be in this equation, because that's what we're trying to find. But Any of the other four we can use because we have so much information. So if we were to just pick one, because they should all give the same answer, if we were to pick v equals u plus at and substitute in the values, we know that v is equal to 2i minus 3j plus 2, the time, times by 3 over 2i minus 2j. And so if we expand out these brackets, firstly on the far right, we have the velocity is equal to 2i minus 3j plus 3i minus 4j. And so if we add the I terms and the j terms together separately, we have a final equation that the velocity between O and A, the final velocity, is equal to 5i minus 7j. And therefore we know that this is also the initial velocity between A and B. And we can use that now in an equation for A and B. So if we now have enough information to consider between A and B, as opposed to O and A, the first thing we want to do before we construct a Suvat equation, just to get more information about between A and B, is think about the fact that we were told that the direction of motion of P is northeast. And if we were to draw that on a diagram, where this is north and this is east, we know that if we label these as north and east, that northeast, if it's exactly northeast, must be exactly in the middle of these. And therefore, if it's exactly in the middle of these, and this is a 90-degree angle, then it must have an angle of 45 degrees, kind of above east. And if we think of this as a vector, because we know that if the direction of motion of P is northeast, that this is kind of the direction of the velocity. So if we think of this as velocity, for this angle here to be exactly 45 degrees, we must have to go along kind of east the same amount that we go up north. So if we're considering this as a vector, the I component, because this is kind of the I-axis, must be the same as the j component. So if we write this information down, that the I component has to be equal to the j component, and this is of the velocity between A and B, we know that although we don't know the velocity between A and B, we can use this information in a Suvat equation, because we know that the I component must be equal to the j component. So if we were to now construct a Suvat equation, kind of bearing this in mind, so we know that the displacement between A and B, we've not been told anywhere in the question, we haven't worked it out, so we don't know this displacement. The initial velocity is the same as this final velocity for O and A, so this is equal to 5i minus 7j. The final velocity we don't know, but since we've just found out that the I component of the final velocity must be equal to the j component, we do know something about this. So if we keep this in our equation, and say that we don't know it, but we want to use it in our equation with a question mark, the acceleration we've been told in the question is 4i plus 8.8j. And last of all, the time we don't know, but that's what the question's asking us to find. So we definitely need to keep this in our equation, because that should be our kind of final result. So the one equation that has all of these terms but s, the displacement, in, is the equation v equals u plus at. So if we substitute in the values here, we don't know velocity. We know that u is 5i minus 7j, and this is plus 4i plus 8.8j, all multiplied by t. Now, if we expand out these brackets on the far right, just so we can kind of get everything in terms of I and j, and if while we're at it, if we do this, we group the I terms and the j terms together separately, we know that 4 times t is 4t, so for the I terms we're left with 5 plus 4t I, and for the j terms, 8.8t take away 7 is what we're left with. So now that we have this expression, and we have it in terms of this final velocity, and luckily what we know about this final velocity is that the I component must be equal to the j component, which means that this 5 plus 4t must be equal to this 8.8t take away 7. So if we write that out as an equation, we can see that what we're left with
is an equation with one unknown variable, which is the time, which is what our question is asking us to find. So if we now rearrange this for time, we take away 4 from both sides, we're left with 5 equals 4.8t, take away 7, and then if we add 7 to both sides and divide by 4.8 to find just what t is, we find that in the end, t is equal to 2.5 seconds. And this question is worth 4 marks, and our first mark is a method mark, and it comes from using a Suvat equation to find what the velocity is. So we get a method mark for doing it, and an answer mark for getting the right answer. And now we get our third mark as a method mark for constructing an equation using Suvat again, with all of these values that we've done. So just a method mark for attempting to do this. And then we get our last fourth mark as an answer mark for doing this correctly, equating the I and j components and finding that t is equal to 2.5 seconds. A plank AB of mass m and length 2a rests with its end A against a rough vertical wall. The plank is held in a horizontal position by a rope. One end of the rope is attached to the plank at B, and the other end is attached to the wall at the point C, which is vertically above A. A small block of mass 3m is placed on the plank at the point P, where AP equals x. The plank is in equilibrium in a vertical plane which is perpendicular to the wall. The angle between the rope and the plank is alpha, where tan alpha is equal to 3/4, as shown in figure 3. The plank is modelled as a uniform rod, the block is modelled as a particle, and the rope is modelled as a light inextensible string. Part A wants us to use the model and show that the tension in the rope is 5 mg multiplied by 3x plus a, all divided by 6a. So the first thing we want to do with this question is we've been given a lot of information, and not all of this is marked on the diagram, or we can infer more things from what we've been given that we can add to the diagram. So one of these things is we're told that this plank AB has a mass of m. And if it has a mass of m, this means that because of the equation F equals ma, where F, the force, is weight in this case, we can say that the weight of the plank is mg. Mass is m, and the acceleration here is gravitational acceleration, which we call g. So if the weight of the plank is mg, we now need to know where we can mark this weight if we were to draw it as an arrow acting downwards. So where does this weight act? And the way we know this is we're told at the bottom of the question that the plank is modelled as a uniform rod. And what this means is that the weight acts in the middle. And the middle here would be, if this whole thing has a length of 2a, the middle, the midpoint of this, is when it's a in on either side. So if we drew this as the weight of the plank, mg, where this length here, from A to the point where this weight acts, is equal to A, because that's halfway along the plank. Another mass we're told is that this small block here, at the point P, this block has a mass of 3m. So using the same principle we did for the weight of the plank, mass times by acceleration is equal to the weight, where acceleration is g. We know that the weight of this block is 3 mg. So this is two weights that we can add onto the diagram. Another thing that we can mark on this diagram is the tension. We're told in the question that there is tension in this rope because this is what we're trying to show, something that it's equal to. And we know that if this rope is holding the plank kind of upwards when it's attached to the wall, there must be some kind of tension in this rope. So if we mark the tension on as acting towards the wall, away from the plank, if we mark that with a T, now we can actually go further with tension, and the way we can do this is we can componentize it. So it would be quite useful in this case to componentize the tension now. We could do it later if we needed to, but we will generally need these horizontal and vertical components of things like tension. And the reason for this is if we were resolving up or down or horizontally in either direction, we would need a vertical and a horizontal component of this tension that we could use in our calculations. We can't use one that has it's at an angle. And if we were taking moments, for example, we need something that's perpendicular to the Planck, and this tension is not perpendicular, so we need to find a component of the tension that is perpendicular. So if we were to do that and draw a vertical component on here that is perpendicular, we know that if we were to turn this into a right angle triangle with both components, this angle up here is alpha, just because of the rule that says that these two alternate angles are equal. So if this is alpha, then we know that for this component here, which acts upwards, we have an opposite and a hypotenuse, and so we need the sine rule, and so we can write this as t sine alpha. And if we were doing the horizontal component, which acts this way, it would be t cos alpha, because we have the adjacent and the hypotenuse. So now that we have all that we can marked on the diagram that we need for now, at least, we can go back to the question. So we want to show that the tension in the rope is equal to this 5 mg times 3x plus a divided by 6a. And one way we can do this, if we think about a way to kind of incorporate all these terms that we have, because we have an a, we have an x, we have an m, and we have a t, all in this formula. And one way that we can incorporate all of this in a calculation is to take moments. And the way we'd know what point to take moments about is we would take moments about point A. And the reason for that is because taking moments around the point A gets rid of the need to calculate any of the forces that are acting on the point A that we might not know, that we haven't been given a value of. So it kind of gets rid of unnecessary calculations if we take moments around the point A, and it then allows for all the terms that we need to find. We know that we need tension, mass, this x and a value, and they would all be present if we took moments about A. So if we did that, and we took them clockwise, so moments about A, we can say that first of all, because we're going clockwise, this weight of the Planck that acts down, we know that moments is the distance times the force, where these are perpendicular. So we know the distance, this is A, and the force, which in this case is weight, is mg. So our first clockwise moment is A multiplied by mg. And now this is added to another clockwise moment we have, which is from A to P, and then the weight of the block that's at P. So we know the distance from A to P is x. So we have x multiplied by the force, the perpendicular force, which is 3 mg. So these are all of our clockwise moments around A. And then we have one anti-clockwise moment, and that is this component of the tension. And we know the distance from A to B is 2a. So, and this is take away because it's an anti-clockwise moment. So this is take away the distance 2a multiplied by t sine alpha, the component. And these are equal to 0. And we know this because we're told that the Planck is in equilibrium in a vertical plane. This is something we're told in the question. And one of the conditions of that we can take from it is that the moments about a point are equal to 0. And so the moments about A we can say are equal to 0. So if we went to solve this, the first thing we would want to do is find out a way to get rid of this sine alpha, because we can see that in our final answer we don't have anything related to sine alpha in here, and so we know we need to get rid of this. And the way we can do that is using the fact that we were told in the question that tan alpha is equal to 3/4. So if we drew out a right angled triangle here, where alpha is this angle here, if in general tan alpha is equal to opposite over adjacent, we know that the opposite must be 3 and the adjacent must be 4, because here tan alpha would then give 3 over 4, which is what we've been told is true. So if we use Pythagoras to find this final side, the hypotenuse, we know that the square root of 4 squared plus 3 squared is 5. And we can use this right angle triangle to find values for sine, cos, and tan of alpha. So we know that tan of alpha is equal to 3 over 4. We've been told this in the question. Sine alpha, in general, is opposite over hypotenuse. We know the opposite is 3 and the hypotenuse 5, so it's equal to 3 over 5. And cos of alpha is adjacent over hypotenuse, where we can see the adjacent is 4 and the hypotenuse is 5. And so cos of alpha is equal to 4 over 5. So now that we have all of these values, we can see that we can replace this sine alpha here with 3 over 5, as we've just found that they're equivalent. So if we rewrite this and we multiply terms together as well, we have amg plus 3xmg, take away, and now we have 2a times by t multiplied by 3 over 5. So we have 6ta over 5. So now that we have all of these terms equal to 0, we can do some rearranging. So we know in the end we need to find that tension is equal to something. So it would help if we first tried to rearrange this equation in terms of t, so we can find what tension is equal to. So if we move the term that has a t in it, which is minus 6ta over 5, if we add this to both sides, we're left with 6ta over 5 being equal to amg plus 3xmg. And now we have this, we can see that on this right hand side we have an mg in both terms. We have one here and one here. And so we can factorise this out. So 6ta over 5 is now equal to mg bracket a plus 3x. And now we have this. We just want to simplify this left-hand side, so we're left with just t. And so one way we can do this is if we multiply by 5 and then divide by 6 to get rid of this fraction of 6 over 5 here. If we multiply by 5, divide by 6, we're left with ta being equal to 5mg. And if we rearrange this bracket of a plus 3x to 3x plus a, simply because that's the form we've been given in the question, so we have 5mg multiplied by 3x plus a divided by 6. And then to get t by itself completely, if we divide by a, we have that t is equal to 5mg multiplied by 3x plus a divided by 6a. And you can see that this is the same form that we've been asked to show in the question all the way up here. These are equivalent. Now this question is worth 3 marks, and our first mark is a method mark, and it comes from taking moments about A. So even attempting to do this, regardless of your outcome, gets a method mark. And then we get a further answer mark for doing this correctly. So writing out a formula for the moments about A, putting in the right numbers, this all gets us another mark. So if we write it on here as another answer mark. And then lastly, we get an answer mark for getting the correct answer. So ending up with t equals 5mg times 3x plus a, all divided by 6a, is our last mark. The magnitude of the horizontal component of the force exerted on the plank at A by the wall is 2mg. Part B asks us to find x in terms of A. So we know that if this force is exerted on the plank by the wall, it must act, if we were to draw it on the diagram, in this direction, kind of outwards from A, because this wall is exerting it onto the plank, so it would be in this direction. And we know that the magnitude of this component of the force is 2mg, so if we write that on. Now if we look at the diagram, we can see that there are only 2 horizontal forces or horizontal components of forces in this diagram at all. We have this 2mg component and we have the T cos alpha component of the tension on the rope. And since there are only two horizontal components, and we know that the plank is in equilibrium, we're told this in the question, if the plank is in equilibrium, then if we were to resolve horizontally, it doesn't really matter which direction. So if we just resolve to the left, the way that the component of the tension is going, if we resolve that direction, we know that the force that's acting in this direction is this one, T cos alpha, and the force that's acting against this, and therefore would be negative, is 2mg. And we can say that because this is all in equilibrium, this is equal to 0. F equals ma, where a is 0, is the F equals 0. These are the forces, T cos alpha and 2mg, and we're resolving to the left. So this is all equal to 0. So if we rearrange this, we can say that T cos alpha is therefore equal to 2mg. Now, what we know from part A is that another way we can write T is like this, 5mg 3x plus a divided by 6a. And now cos alpha, if we go back again to part A, where we drew a right angle triangle to find values for cos alpha, sine alpha and tan alpha, we have this triangle where sine alpha is opposite over hypotenuse and therefore 3/5, and cos alpha was adjacent over hypotenuse, which is 4/5, and tan alpha is in the question and we don't need it for this currently in the question. So we know that if it's t multiplied by cos alpha, we have t as this equation here, and cos alpha is equal to 4/5. So we've just found out with this right angle triangle. So we have t times by 4/5, and this is still equal to 2mg. So if we do this calculation, we times this large fraction t by 4/5, just to simplify it all to one fraction. We have 20mg 3x plus a, and this is divided by 30a, 6a times 5 is 30a, and this is still equal to 2mg. Now if we want to get rid of this denominator, because if we remember, this question wants us to find x in terms of a, so we need something that is x equals, we need x as the subject, is essentially what this question is asking for. And therefore, if we want to get x by itself, and we have x up here, we need to essentially move most of this fraction over to the right hand side. So if we do this by first multiplying both sides by 30a to get rid of this denominator, we have 20mg multiplied by 3x plus a is equal to 2mg times by 30a. And now we can see that on both sides we have an mg. We have an mg here and an mg here. So if we divided both sides by mg, this would cancel out and we'd be left with 20 multiplied by 3x plus a is equal to 2 times 30a, which is 60a. And now, again, we're still looking for x in terms of a. So if we divide both sides by 20 to get rid of this 20 that's on the outside of the brackets, we have 3x plus a is equal to 60a over 20, which is equal to 3a. And then if we take away a from both sides, we have 3x is equal to 2a. And then if we divide both sides by 3, so we can get x by itself, we are finally left with x is equal to 2/3 of a, and that's our question. We found x in terms of a. And this question is worth 2 marks, and we get our first mark as a method mark, and it comes from writing out this formula here. So saying that T cos alpha is equal to 2mg, and then we substitute in our values for T and cos alpha, and that's our first method mark, so just doing this. And then our second mark is an answer mark, and that comes from solving that equation and then getting that x is equal to 2/3 A as our answer, and that's both marks of the question. The force exerted on the plank at A by the wall acts in a direction which makes an angle beta with the horizontal. Part C asks us to find the value of tan beta. So we know that this force here, the 2mg, as we were told in part B, is the horizontal component of the force exerted on the plank by the wall. And we know now that the actual force acts in a direction that makes the angle beta with the horizontal. So if we were to draw that on, and we don't know what beta is, but we know that it's at some angle beta to the horizontal here. And now this means that if it has a horizontal component, it also has a vertical component, so we can get this being the resultant force. So the vertical component will act upwards along the wall here. And although we don't know what this is, we know that since this wall is rough, we're told here it's a rough vertical wall, that there is some kind of friction between this plank and this wall. And so we can assume that this force here is the frictional force, F. So if we just call this F for now, as we don't know what it is. But what we do know is that since we know the horizontal component, if we were to find this vertical component, we can find this the force exerted on the plank, which therefore means we can find tan beta. So if we wanted to find F, there are two ways we can actually do this, and both are credited in the mark scheme. The first way is that we can resolve, and we can resolve vertically, using all the forces that are acting vertically, and we can resolve this. Or the second way is that we can take moments. So if we were to take moments, we would have to take them about B, about this point here. And the reason we wouldn't take them about A, like we did in part A, is because if we took them about A, that would eliminate this force and this force and this force, or rather these two components of this force, because we're taking them about A. But we don't want to eliminate these, so the way that we can assure that doesn't happen is by taking moments about B. So if we took moments clockwise about B, we know that the force is acting clockwise about B. We have only one, and that force is this F, friction force, at the point A. So we know that the distance between B to A is 2A. So moments is the distance times the perpendicular force, or the force times the perpendicular distance. So we know that it's 2A is the distance, times by F, the force. And now the rest of the forces are all acting anti-clockwise about B, one of them being this weight of the plank. So we know that this is a distance of A away from B, because this is in the centre. So if here to here is A, then here to here must also be A. So we know that this is take away, because it's anti-clockwise, A times by mg, and then also take away our other anti-clockwise force, which is this one, the weight of the block at P. And now the distance between B and P must be 2A take away x, because we know the distance from A to P is x, and therefore the distance from P to B, or B to P, is 2A take away x. So we know that this is take away 2A take away x is the distance, and then this is multiplied by the force, which is the weight, 3mg. And now because this is all in equilibrium, this is equal to 0. So now we have this, we can try and solve it. And as I stated before, the aim of this is to try and find what f is. And so we need to try and rearrange this in a way that we can have f as the subject, f equals, and then everything else.
So if we do this, if we add this AMG and this to a take away x times by 3mg, if we add this to both sides, then we'll end up with this term, which is the term with an f in it, by itself on the left-hand side. So if we do this, we are left with 2af is equal to AMG, and if we expand out this bracket while we're at it, 2a times by 3mg is 6AMG, and then we have take away minus x times by 3mg is minus 3x mg. And so now what we do is, since we have an AMG and a 6AMG, we can add these together, and we're left with 2AF equals 7AMG take away 3xmg. Now we know from part B that x is equal to 2/3 a, and that's what we found as our answer for part B. And therefore, if we substitute this in for x in this term here, 3xmg, we substitute that in, we have 2AF is equal to 7AMG, and then take away 3 times by 2 over 3a, and this leaves us with take away 2a mg. And now we'll see that every single term here, so 2af, 7amg, and minus 2amg, all have an a term in them. And what that means is we can divide both sides by a to get rid of this. So now we're left with 2f is equal to 7mg take away 2mg. And so we can rewrite this to get this in terms of f. That f is equal to 7mg take away 2mg all over 2. And so we can simplify the numerator. If we have 7mg take away 2mg, this is equal to 5mg. So we end up with a final equation that f is equal to 5mg over 2. So now, we're looking back at the diagram, we have this component, the vertical component, and the horizontal component of this force. And so we can use this to find the angle beta. So if we drew this out again as a separate triangle, where this is f here, 5mg over 2, and this horizontal component here is 2mg, then we know that if this is the force, it's at an angle beta. And so if we wanted to find this angle, we could use trigonometry. This is a right angled triangle. If we were to draw this dotted line is equivalent to this line here, and so this is also 5mg over 2. And this is a right angled triangle. So if we wanted to find the angle beta, we have an opposite and an adjacent, so we would use tan, and we would write that tan of the angle, which is beta, is equal to opposite over adjacent, where opposite is 5mg over 2 over 2mg, the adjacent. This can also be written as tan beta is equal to 5 over 4, because this 2, the denominator of the fraction in the numerator, multiplies with 2mg, and now we have an mg on the top, on the numerator and the denominator, which cancel out, and we're left with 5 over 4. And the question is asking us to find the value of tan beta, and that's what we've done. We've said that tan beta is equal to 5 over 4, and so we've answered the question. Now, this question is worth 5 marks, and we get our first mark as a method mark for taking moments about B. We would also get a method mark if we did it a different way, which I mentioned at the start, and that was to resolve vertically instead. Either method works, and either method would get you the marks. But if we were resolving about B, this would be our first method mark, and then we would get a method mark for finding an expression in terms of f. So getting all of this working is an answer mark. So if we mark it as
here. We get an answer mark for doing all this. And then we get another answer mark for the final answer of f. So saying that f is 5 mg over 2 gets us an answer mark. And now we get another method mark for writing an expression in terms of tan beta. We had this right angle triangle here, and then we stated that therefore tan beta is 5 mg over 2 mg, and this gets us a method mark for doing this at all, regardless of our outcome. And therefore, we get our last answer mark for stating that tan beta is equal to 5 over 4. So concluding the actual answer of the question gets us the last mark of 5. The rope will break if the tension in it exceeds 5 mg. Part D asks us to explain how this will restrict the possible positions of P. You must justify your answer carefully. So if the rope will break if the tension exceeds 5 mg, we know that the tension has to be 5 mg or less. So if we were to write this as an inequality, we would write that T has to be less than or equal to 5 mg for the rope to not break. Now in part A, we found another way that we can write T, and that was to write it as 5 mg multiplied by 3x plus a, all divided by 6a. So if we rewrite this expression, that T, written like this, has to be less than or equal to 5 mg, then we can actually solve this expression for x. So if we multiplied both sides by 6a, we're left with 5 mg multiplied by 3x plus a is less than or equal to 5 mg multiplied by 6a. And now we can see that on both sides we have a 5 mg here and here, and therefore if we divide both sides by 5 mg we can cancel these out, and we're left with 3x plus a is less than or equal to 6a. And now if we take away a from both sides, so we're left with x on the left hand side, we have 3x is less than or equal to 5a, and therefore x, if we divide both sides by 3, is less than or equal to 5 over 3 multiplied by a. So what this is telling us, if we look back up at the diagram, is that x, which is this distance here, x has to be less than or equal to 5 over 3a. If it goes any more than this, then the tension won't be less than or equal to 5 mg, and then the rope will break. So x is restricted to being less than or equal to 5 over 3a, and we know that x is the position of P relative to a. So if x gets smaller, P moves towards a, and if x gets larger, P moves away from a. And therefore, the positions of P are restricted because we can say that P must be no further away from a than 5a over 3, else the rope will break because the tension will have exceeded its maximum limit. Now this question was worth 3 marks, and we get our first mark as a method mark from writing out this equation, so saying that T must be less than or equal to 5 mg, and substituting in T with this expression that we found from part A gets us a method mark. And then we get an answer mark for doing this correctly, so ending up with x being less than or equal to 5 over 3a. And then lastly, we get an answer mark for putting this into a sentence, so saying that therefore, for the rope to not break, the block can't be any more than 5a over 3 away from a, or anything equivalent to that, which we've done in this last sentence here for all 3 marks. There's a ball at a target. At the instant when the ball leaves the boy's hand at the point A, the ball is 2 meters above horizontal ground and is moving with speed u at an angle alpha above the horizontal. In the subsequent motion, the highest point reached by the ball is 3 meters above the ground. The target is modelled as being the point T, as shown in figure 4. The ball is modelled as a particle moving freely under gravity.
Using the model, part A asks us to show that u squared is equal to 2g divided by sine squared alpha. Now, the first thing we want to do on this question is consider the speed, because we've been given this speed to be acting at an angle above the horizontal. And the problem with this is in calculations like this, we tend to need to resolve vertically and horizontally. We don't normally resolve at this random angle alpha, just because it isn't really convenient with everything else. And so for our calculation, if we need to resolve vertically or horizontally, we need to find a way that we can speak about the speed in these terms. And the way we can do that is we can resolve vertically and horizontally. So if we first resolve vertically upwards, we can see that we have this right angled triangle here, where this is the opposite of this angle, and this is the hypotenuse. And we know that opposite and hypotenuse means we need to use the sine rule, and so that we can say that this vertical component is equal to u sine of alpha, because it's like if we had sine alpha is equal to opposite over u, so we times both sides by u to get this equation for the opposite. And if we do the exact same thing horizontally, acting in this direction, we have an adjacent and a hypotenuse, so this ends up being equal to u cos of alpha. And so now that we have our speed resolved vertically and horizontally, it should make calculations much easier. And the other thing that we can mark on this diagram, using the information we've been given, is the fact that we're told that the ball's modelled as a particle moving freely under gravity. And what this actually tells us is that the acceleration, when we resolve vertically downwards, the acceleration is the gravitational acceleration, which we can call g. And this is the only acceleration that acts on the ball. So if we mark this on, that the acting downwards, and we know it's acting downwards just because gravity acts downwards, so that's the way that this acceleration acts, that we have this downwards acceleration of g meters per second squared. And this is all the information that we can currently mark on the diagram that we haven't already been given. So now, if we look back to our actual question of what we need to show, this expression here, we can see that to get this, first of all, we will need to use one of the constant acceleration formula. And the way we know this is partially because this is a projectile motion question and they do tend to use these Suvat equations. But also, we've been given this speed, we have these distances above the ground that we could use as displacement, and we have this acceleration. So all of these are things that we would use in these equations, and so these are all kind of hints about what we should be doing. But what we don't know with these equations is whether we should resolve vertically or horizontally, because either would be valid, but which one would get us this exact expression? And the way we know that is if we look at this expression, we can see that we have a g, and we can see we also have a g here in our acceleration that acts vertically downwards. And we can see that we also have a sine alpha, which appears when we resolve vertically for our speed. So these both occur when we resolve vertically. So to get them in our equation, we're going to need to construct a Suvat equation where we resolve vertically upwards, just because upwards is the direction that the ball moves. So first of all, we have s, and our displacement here, if we form a Suvat equation between A and this highest point here, just because these are the 2 points we know the most about currently, we know that our displacement from here to here must be 1 metre, because we've gone up from 2 metres above the ground to 3 metres above the ground. So the displacement of that is 3 take away 2, which is 1. And now our initial velocity is this velocity at the point A when we resolve vertically, which we previously wrote out to be equal to u sine of alpha. And v is the velocity at this point here, the highest point. And although we've not been told this in the question, a general assumption we can make about the velocity at the highest point of projectile motion is that we can say it's equal to 0 meters per second. This is just kind of an assumption we make. And next we have the acceleration of the ball, and as we stated previously, when we resolve vertically downwards, the acceleration of the ball is g meters per second squared, which means if we resolve vertically upwards, it must be the opposite of this, which would be negative g. We're acting in the opposite direction that the acceleration acts. And lastly, we have t,
and we don't actually know what the time is, but we also don't need to know. We have enough information here, as well as the fact we can see in this final expression there has nothing to do with t, time. So we can see that it's not going to be in our end result, and so we don't need to know it. So now, if we think of the 5 constant acceleration formula, which one has all of these but t, time, then the equation we need to use is v squared is equal to u squared plus 2as. So if we substitute in these terms that we have, 0 squared is just 0, and then we have u sine alpha squared plus 2 multiplied by minus g multiplied by 1. So if we expand out these brackets we have on the right hand side, u sine alpha all squared is the same as u squared sine squared alpha, because we have to square both terms, and then 2 times by minus g times by 1 is just minus 2g. So now if we want to rearrange this in the format we've been given in this question, we need u squared by itself. So if we add 2g to both sides and divide by sine squared alpha, that's what we'll end up with. We'll have u squared is equal to 2g divided by sine squared alpha, which is exactly the form that we want to give in the question. And now this question is worth 2 marks, and our first mark actually is a method mark, and it comes from resolving vertically, which we've done here. And our second mark is an answer mark, and it comes from ending up with what we've actually been given in the question. So getting the right answer in the end is our second mark. The point T is at a horizontal distance of 20 metres from A and is at a height of 0.75 metres above the ground. The ball reaches T without hitting the ground. Part B asks us to find the size of the angle alpha. So first of all, if we just mark on the information we've been given to the diagram, we know that this distance from T to the ground is 0.75 metres, and this distance from A to T is 20 metres. Now, the first thing to note is we can't just find the angle A with one Suvat equation like we did in part A. We're going to need a simultaneous equation because we just don't have enough information to simply find alpha straight away. Because you may be able to see, if we just resolve, for example, horizontally, we're going to end up with something to do with u, and that is another term that we don't know, which means we can't just find alpha. So we're going to need a simultaneous equation where we might be able to cancel out u or find u, which will therefore lead us to be able to find alpha. So if we do this, one way we can form a simultaneous equation in this kind of context is if we resolve vertically and then horizontally, we should have 2 equations with very similar terms that we should be able to equate or substitute into one another. So first of all, if we resolve vertically upwards, but now between A and T as opposed to A and this highest point, we know that the displacement between A and T is going to be negative because we've gone down from being 2 metres above the ground to being only 0.75 metres above the ground, which means we're going to end up with a negative displacement, and that displacement is going to be negative of 2 minus 0.75 because that's the difference between this point A and this point T. So we know that our displacement in the end is minus 1.25. Now u, our initial velocity, when we resolve vertically upwards, is going to be this component here, u sine of alpha. And our final velocity, we don't know. So we've not been told anything to do with the final velocity at t, but we also don't need to know v. And the reason for that is that if we were going to make a simultaneous equation, we can say that the vertical component of our final velocity is not necessarily the same as the horizontal component of our velocity. So we wouldn't be able to equate these two v's, and that would make a simultaneous equation quite complicated. So although we don't know v, we also don't need to know v. It's better to leave it out of this equation. And now a, when we resolve vertically upwards, as we did in part A, we know is minus g. And t, although we don't know the time, we can also say that we'd like to find the time because, thinking back to our simultaneous equation, we know that the time it takes to get from A to T when resolving vertically is going to be the same as when we resolve horizontally. So these are something that we could equate, and so could be helpful in our simultaneous equation. So if we say that we don't know T but would like to find T, then we need to pick the constant acceleration formula that has all of these terms but v, and that equation is S is equal
to ut plus half at squared. So if we substitute in the terms, we are left with minus 1.25 is equal to u sine alpha multiplied by t plus a half multiplied by minus g multiplied by t squared. And so we can't do much with this now because we have so many unknown terms like u, alpha and t. But the one thing we can do is to just simplify a little bit by expanding out these brackets on the end. So we're left with minus g over 2 multiplied by t squared on the end. And this is as far as we can simplify it for now, which is why we need to do a simultaneous equation. So if we do the exact same thing, but now resolve horizontally, if we resolve to the right, just because that's the direction the ball's moving in our diagram, then our displacement must be 20 meters, because we know, as we're told in the question, that the point T is at a horizontal distance of 20 meters from A, so our displacement is 20. Our initial velocity when resolving horizontally is the horizontal component of u, which we found to be u cos of alpha. Final velocity, we don't know but also don't need to know for the exact same reason that we didn't use v when resolving vertically. And our acceleration, when we resolve horizontally on a projectile motion question like this, the acceleration is actually 0 meters per second squared. There's no acceleration resolving horizontally. And lastly, t, we don't know, but we'd like to know, for the same reason we did when resolving vertically, which was that this t here and this t here are exactly the same, and this could come in handy in our simultaneous equation. So again, the only equation that doesn't have v in it is the equation s is equal to ut plus half at squared. So this time, if we substitute in the values we have 20 is equal to u cos alpha multiplied by t. But this time, it's plus a half times by 0 times by t squared. So anything multiplied by 0 is 0, so this is as far as we can do this equation. However, if we look at this equation here and this equation here, we can see that they both have a t in them, but we don't want t in our final answer because we're trying to find alpha. And so a good way to cancel out these t's, as well as kind of bring these two equations together, is to substitute in one as t. So if we rearrange this bottom equation we have here in terms of t, and so we're left with t being equal to 20 divided by u cos alpha, we can actually substitute this into our first equation. If we call this equation 1 and this equation 2, and we say that we want to substitute in 2 into 1, then we'll actually be left with something that's just in terms of u and alpha, which should help us find what alpha is. So now we're left with minus 1.25 is equal to u sine alpha multiplied by 20 over u cos alpha, and then this is take away g over 2 multiplied by 20 over u cos alpha, all squared. So now if we want to simplify this a little bit to make it less complicated, we're going to end up on the right hand side with u sine alpha times by 20 over u cos alpha. And so if we've got a u on the numerator and the denominator, these are going to cancel out. And if we have a sine alpha on the numerator and a cos alpha on the denominator, we know that by definition, sine alpha over cos alpha is equal to tan alpha. So this first two brackets multiplied by each other will actually simplify down to 20 tan of alpha. And now, if we do the exact same thing with the second terms in this equation, if we first expand out this bracket of 20 over u cos alpha all squared, 20 squared is 400, and then this is divided by u squared cos squared alpha. And so if we now multiply this all by minus g over 2, we'll find that since we have a 400 on the numerator and a 2 on the denominator, 400 divided by 2 is 200. So we can actually simplify this now to 200g divided by u squared cos squared alpha. And so now we have this equation. Although it's simplified, we can see that we have this tan alpha and a cos squared alpha, so we can't solve for alpha just yet. But what we can do is use an equation that we had in part A for u squared, because if we substitute that in, we've now gotten rid of all the u's, which would be very helpful for finding what alpha is. And that equation, if we write in that we should substitute this in, the equation from part A was that u squared is equal to 2g divided by sine squared alpha. And we can substitute this in because we have a u squared here. So if we were to do that, we are going to end up with minus 1.25 is equal to 20 tan alpha minus 200g divided by 2g over sine squared alpha multiplied by cos squared alpha. So now we want to simplify this fraction a little bit because it's a bit complicated at the moment. We can see that on the denominator we have 2g times by cos squared alpha over sine squared alpha if we expand out those brackets, and cos squared alpha over sine squared alpha is equal to 1 over tan squared alpha, because it's kind of the inverse of sine squared alpha being over cos squared alpha. So now we end up with 200g over 2g over tan squared alpha. And we can rewrite this once again to simplify it even more so we don't have a fraction within a fraction. That this can actually be rewritten as 200g times by tan squared alpha over 2g. And then we have a 200g over 2g, which then cancels down to 100. So eventually, this fraction all cancels down to take away 100 tan squared alpha. And so you can see now that what we have resembles a quadratic equation because we have a tan squared alpha, tan alpha, and then just a number, a constant. And so if we rewrite this to look even more like a quadratic, in that it's equal to 0, if we add 100 tan squared alpha to both sides and take away 20 tan alpha, we're left with 100 tan squared alpha, take away 20 tan alpha, take away 1.25 is equal to 0. And so if we were to solve this as a quadratic equation, you can see that we would end up with something to do with tan of alpha, which will allow us to find alpha. So to solve this quadratic equation, we can go about it one of two ways. We can factorise this, as we would any quadratic equation, or we can use the quadratic formula. So if we were to go down the second route and use the quadratic formula, generally the quadratic formula is that x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So in our context, instead of x, we have tan of alpha, and then our a is 100, our b is minus 20, and our c is minus 1.25. So if we substitute these in, minus 20 is just 20, and then it's plus or minus the square root of minus 20 squared minus 4 times by 100 times by minus 1.25. And then this is all divided by 2 multiplied by 100. So if we simplify this down a bit, more specifically what's inside this square root, we're left with tan alpha being equal to 20 plus or minus the square root of 900 divided by 200. And we can see that we're going to end up with two different values of tan alpha because we have plus or minus involved. So first of all, if we do 20 plus the square root of 900 divided by 200, we're left with tan alpha being equal to 1 over 4. And if we do tan alpha is equal to 20 minus the square root of 900 over 200, we're left with tan alpha being equal to minus 1 over 20. And so to find alpha from these, we just have to take the inverse of tan. So here, the inverse of tan of 1 over 4 is 14.0 degrees to 3 significant figures. And here, alpha is equal to minus 2.86 degrees, again, to 3 significant figures. Now the problem with this is we can only have one value of alpha, and the way we can figure out what that is if we think about this angle up here, this angle can't be negative because we can see quite clearly that it's pointing up, the ball is thrown upwards. And so this angle can't be negative. But what we can do with an angle involving tan is we can add 180 degrees on to get the next angle. So if we visualise that on a graph, it would be the next value of alpha along. And in this case, adding 180 onto minus 2.86 gives us 177 to 3 significant figures. But again, we can see that this angle here, alpha, needs to be between 90 degrees and 0 degrees, because if it was any more than 90 degrees, it would be pointing somewhere out here in this direction, which is away from the target t. It has to be within this. If this is 90 degrees, it has to be this or less. And so we can say that even if we were to add 180 degrees onto this, we still wouldn't get a value of alpha that makes sense in the context of this question. And so we can say, if we go back to our values of alpha, that we can discard minus 2.86 degrees as an answer, because that wouldn't make sense, and adding 180 degrees on still wouldn't make sense. And so we can conclude that the answer to our question is that alpha is equal to 14.0 degrees to 3 significant figures. And this question is worth 9 marks, and if we go back to the start of our workings out, the first 2 marks come from when we resolved vertically upwards. We get a method mark for just doing it, and then a further answer mark for doing it correctly and ending up with this expression here. And then we get another 2 marks for doing the exact same thing but resolving horizontally. So a method mark for doing it and an answer mark for doing it correctly. Our next mark is actually a method mark, and it comes from substituting in this equation for t into this equation 1. So doing this gets us a method mark, and then we get another method mark for substituting in this expression here for u squared. So doing that is a further method mark. And then we get an answer mark for then ending up with this quadratic in terms of tan of alpha, and then a further method mark for solving this, and you'd get a mark for doing this by factorising or by using the quadratic equation. Either are fine, but that's a method mark. And our last mark, our 9th mark, comes from ending up with this answer of 14.0 degrees for alpha. Part C is asking us to state one limitation of the model that could affect your answer to part B, our answer to part B being the value of this angle here. Now, if we think about this question in a more kind of real-life sense, then we know that this ball goes from A to T, where T is a target. And this target isn't going to be one singular point in space where the ball has to hit this exact point for it to hit the target. The target will kind of be somewhere where the ball can hit different points on it, and it still hit the target. It's not going to be one singular point. And therefore, if there's a range of kind of places that you can hit this target, then there's also going to be a range of different ways that this ball can be thrown to hit it in terms of the angle that you throw it at. So you might be able to throw it a little bit lower than what this arrow is indicating. So an angle a little bit smaller than alpha, and it might go in this direction, but it might still hit this target because the target isn't one point. And so we can say that since the target isn't a singular point, it has dimensions, that there must be a range of possible ways that we can throw this ball that will still hit the target. And so there's going to be a range of values of alpha, not just 14 degrees as we found in part B. And this is one possible answer. The mark scheme actually gives a list of different answers you can say. There isn't only one thing you can put. Something else, you could talk about the fact that in real life, there would be air resistance acting on the ball, so the angle might differ slightly, or the ball will have dimensions as well as the target, as well as the fact that the wind will have an effect on kind of the angle that the ball is thrown at and the way the ball is thrown depending on how strong the wind might be on that particular day. And these will all have an effect on the possible values of alpha. So we could also say any of these. And these are all just examples given in the mark scheme. Any valid limitation of this model that will affect the angle will get you the mark. These are all just examples. But stating any one of these, for example, this one about the dimensions of the target, will get you the 1 mark available for the question. Now, part D is asking us to find the time taken for the ball to travel from A to T. And luckily, in part B, we actually found an equation that was to find just that, involving the time taken to get from A to T when we resolved horizontally. And that equation was T is equal to 20 divided by U cos alpha. And now the problem with using this equation straight away is that although we know what alpha is, we don't yet know what U is. And so to use this equation, we need to find out what U is. And the way we can find out what U is use another equation that we found, this time one we found in part A, and that equation is the equation u squared is equal to 2g divided by sine squared alpha. Obviously we could have found another equation in terms of u, but since we already have this one, where we know all the terms apart from u, it's just easier to use one we already have. So we know that if alpha is equal to 14.0, as we found in B, we know that u squared is equal to 2g divided by sine squared 14.0. And so if we square root this and actually solve it in a calculator, we get that u is equal to 18.3, but that's to 3 significant figures. In your calculations, use the entire value just for simplicity if we write down the first 3 significant figures. So now that we have a value for u, we can use our initial equation, and that equation was t being equal to 20 over u cos alpha, again, the one we found in part B. So if we substitute in the values we know, which is u and alpha, t is equal to 20 over 18.3 cos 14.0. And if we solve this in a calculator, we find that t is equal to 1.13 seconds to 3 significant figures. And so this is the time taken to go from A to T, because that's what this original equation was measuring in the first place. And this question was worth 3 marks. And our first mark is a method mark, and it comes from finding u using our value of alpha, which is what we've done here with this equation. And our second mark was a method mark again for using this equation that we've done here and finding what t is. So using the t equals 20 over u cos alpha is our second mark. And our last mark is an answer mark, and it's for ending up with t being equal to 1.13 seconds.